Fusion is a very efficient process that uses hydrogen, the same kind of hydrogen found in a molecule of water, to fuel it. Fuse together two atoms of hydrogen and you release a tremendous amount of energy. Bind all of the hydrogen atoms in a small lake together and you could power the world.
So if you had a reservoir that was, say, a mile across and 50 feet deep, it would supply the world's energy supply for the next 150 years.
Is that possible? Astrophysics professor Rob Goldston and his group at the Princeton Plasma Laboratory think it might be.
We are producing megawatts, millions of watts of fusion power in our current experiments, and we are measuring it in great detail. We know that we're now producing fusion power.
Goldston's reactor uses the same fuel as the sun, hydrogen plasma, or superheated hydrogen gas. But the sun's got a huge advantage. Its immense gravity can squeeze atoms together to get them to fuse. So, to compensate, Goldston's turned up the heat to 100 million degrees Celsius. At those temperatures, the atoms are moving so fast that when they collide, they fuse.
The core of the sun is actually 10 times cooler than the plasmas we make, but much, much denser, much heavier, much more gas there than in our experiments. A lot of people wonder, here I've got a plasma that's at 100 million degrees centigrade. How come everything isn't melting?
There's no substance in the world that can hold something that hot. So to contain the plasma, Goldston uses magnets.
Instead of using gravity in our systems, we use magnetic fields. A plasma is made up of plus charges and minus charges. A magnetic field is very, very effective for holding on to this kind of plasma. The pluses and the minuses spiral along the magnetic field. So if I connect the magnetic field up in a circle, this very, very hot gas that you might think would go everywhere, in fact, will just spiral around the magnetic field like beads on a string. And then the plus charges can slam into each other and give you fusion.
But only for an instant. So far, Goldston's been able to achieve fusion for only a second. That's a far cry from what the sun's been doing for 5 billion years and will continue to do for 5 billion more.